Hey, we're going to find the derivatives of some logs, more specifically the natural log function, and the derivative of the log, natural log u, is 1 over u, and then because of the chain rule, we'll tack on that u prime at the end. So we'll keep that in mind. We might have some other rules we're going to use here, but in general, that's the rule we're focused on. So the first example here is y equals natural log of 3x plus 4x squared. So you can get yourself in a lot of trouble here if you don't pay close enough attention. The way this is written, it should be natural log of just 3x. So you might have a parentheses around that 3x might help you because you want the 4x squared to be separate. So in that case, let's use our chain rule up here. So this is not the natural log of x, it's the natural log of some u. So that u is going to be 3x. So in that case, when we go to take the natural log of 3x, we'll have u is 3x, and u prime will be 3. So we've got everything we need to build this derivative because we know how to take the derivative of 4x squared. So y prime will be, the derivative of natural log is 1 over u, so that'll be 1 over u, which is 3x. And it'll be times the u prime, which is 3. So in that case, here's the u, here's the u prime. And then separately, because of some indifference rule, we'll have plus the derivative of 4x squared, which will be 8x. Now, very easy to see this cleans up a little bit, whether you are paying attention or not. The log part will be 3 over 3x, which will reduce down to just 1 over x. And then plus 8x. So that looks a lot better than the 3 times and everything, but don't think that's going to happen every single time. It really depends on what's in there. So our derivative is 1 over x plus 8x. The next example we have is y equals the natural log of the quantity x plus 6 to the 4th. So we definitely have a chain rule here, but we have something a little bit more interesting. We have the chain rule with a chain rule. So first of all, in trying to do the natural log, we have a u of x plus 6 to the 4th. So in that original chain rule, we'll have u equals x plus 6 to the 4th. But in trying to do that, we have another chain rule. Let's see if I can get another color here, and then we'll go from there. Once again, we get the freeze up. But we have a power function there. So we have some expression inside of our logarithm other than a single variable. And then when we look at that expression, there's something inside the power rule other than a single variable. So we'll say this is an additional. Well, let's use a different color. Additional chain rule. Okay, so in that case, this u, and I could call them something different, but the colors are keeping me straight. This u is x plus 6, and the u prime is just 1. So that's not too hard to do, but let's finish up the blue part here. So u was the square root of, not square root, x plus 6 to the 4th. So u prime is 4 times, going to have a u in there, raised to the 3rd, and then there will be a u prime on the outside. And it may not make a difference in the long run, but it does happen. So let's see here. So that u inside was x plus 6, and then the u prime is just 1, so I really don't need to write it. So the thing inside the logarithm has a derivative of 4 times the quantity of x plus 6 raised to the 3rd. Now I need to go back because I have the derivative of that thing inside. So now I'm going to focus on the logarithm. So y prime, the derivative of the logarithm is 1 over u. And the u that we worked with was x plus 6 to the 4th. And then it's times the u prime, which was 4 times x plus 6 cubed. Now, let's make sure you're okay with that. That's the u, and this right here is the u prime. But if you notice, if you put this on top of each other, there's 3x plus 6's on the top and 4x plus 6's on the bottom. So that can clean up to be just 4 over x plus 6. Whether you clean it up or not is irrelevant. I just want you to see that sometimes they do come out to be something nicer. If you leave it as the previous step, it's fine. Okay, that one is a little bit confusing and takes a lot of care because you have a chain rule, and when you start that chain rule, you find out you have another chain rule. So you have to keep going deeper into the well, and then you have to complete the steps and then walk back up. Okay. All right, so the last one we have here is y equals x cubed times the natural log of 2x plus 4. It's nice to see those parentheses there. But let's see here. What do we have? We have a product rule because we have two things multiplied together. Product rule. So what do we have? We have x cubed being a u, and we have the natural log of 2x plus 4 being a v. So let's see here. If we take the u of x cubed, u prime will be 3x squared. So I'm building a product rule. Now the v is the natural log of 2x plus 4. And I have another chain rule. And inside that chain is 2x plus 4. So that u is 2x plus 4. And the u prime is 2. So finishing out the derivative of v, when we take the derivative of a natural log, we get 1 over the original u, which was 2x plus 4, then times the u prime, which would be 2. And let's just carry this out a little bit further, because that would be 2 over 2x plus 4. I won't reduce that, but you can. Well, it's 1 over x plus 2, but I'm just going to leave it like that. So going back to how I did the product rule, I have a u prime, a v, and a v prime right here. So let's build that product rule. So y prime equals v, natural log of 2x plus 4, times u prime, so that's times 3x squared, plus u, that's x cubed, times v prime, 2 over 2x plus 4. So making sure we can go back and identify everything. Here is the v, here is the u prime, here is the u, and this whole thing here is the v prime. So we did end up with a nice complete derivative that, once again, could probably be cleaned up some, but we're happy with what we have. Thank you.